Okay, so now in this video, we're going to actually try to compute limits using piecewise functions here. So in this note here, I have at the top, it says to compute limits of piecewise functions, we may need to consider the left-hand and right-handed limits first. All right, and so I'm referring to class to this practice 2 here below. Okay, so it says here I have my 3 pieces of my piecewise function f of x. And here it says to find the limit as x approaches 2 of f of x. Okay, so when you look at these pieces, you see that we have this piece in, I'm going to highlight in yellow, x squared for when x is less than or equal to 2. And then we have this piece, 8 minus 2x, when x is in between 2 and 4. Okay, and so we're trying to figure out, right, which piece should we be using then for the limit as x approaches 2 of f of x? Well, what you're noticing is that we're using 2 different pieces coming from the left direction and from the right direction of x equals 2, right? So in this case, we're going to have to consider the left-handed and right-handed limits. Okay, so we're going to consider the limit as x approaches 2 from the left of f of x. Okay, and that's basically because when x is less than or equal to 2, we have a different function in our piecewise than when x is greater than 2. Okay, so we are going to have to consider both left-handed and right-handed limits. Okay, so now what I'm going to do is I'm just going to draw a number line here to get us a little bit more comfortable with this. But basically, here's my x value of 2. And what I'm saying to you is when x is less than or equal to 2, so I'm including, this value here, but so for everything, I'm going to highlight to the left in yellow. Okay, because when x is less than or equal to 2, I'm using x squared, and so that's the piece I'm using when I'm to the left of 2, right, on the number line. Okay, so here, when I'm to the left of 2 on the number line, I'm using x squared. So when I'm trying to consider the left-handed limit, the limit as x approaches 2 from the left of f of x, my function that I'm going to use is x squared. Okay, because here this would be x approaching 2 from the left, right, in yellow here. Okay, now same idea for the bottom part. So from 2 to 4, right, it says that I'm using this function. Okay, but regardless, we see that when we're very, very close to 2 from the right, we're using the function I have highlighted in green, which is 8x minus 2. And so as x approaches 2 from the right, we're going to be using that function I have highlighted in green. So we're going to write the limit as x approaches 2 from the right of 8 minus 2x. Okay, so the number lines are pretty helpful when trying to figure out which function to use when you're coming from the left and which one you're using when you're coming from the right. Okay, so now at this stage, right, for these left-handed and right-handed limits, when you look at these pieces of the function, ask yourself, is x squared continuous to the left of 2? And it is, right? Because x squared is continuous everywhere on its domain. So for all of x values less than or equal to 2, x squared is continuous. And so the reason why I'm bringing that up is what I'm going to do now is I'm going to plug in 2 into the function and get that my limit as x approaches 2 from the left of f of x is equal to 4. Okay, so now here, I'm just going to write oh, at this stage, plug in 2. Oops. For x. Okay, so plug in 2 for x. Okay, and the reason why we can do that is basically because x squared is continuous to the left of 2. Okay. And so remember, right, polynomials like x squared and linear functions like 8 minus 2x, those things are continuous on all real numbers, right? It's domain. And so that's why I'm saying that, of course, the limit as x approaches 2 to the left of x squared is just going to be where I plug in into those values there. All right. So now when I'm doing the limit as x approaches 2 from the right, same idea is going to happen. I'm going to plug in 2 for x. Okay, because to the right of 2, I am continuous. And so that means that I can just plug in 2 into the function. And so this is 8 minus 4, which is equal to 4. Okay. And so now you want to ask yourself, does the left-handed limit match the right-handed limit? And hopefully you say yes, right? Because we got that both of these were 4. So overall, the limit as x approaches 2 of f of x is equal to 4. Okay, let's look at our second example now. So now we have a different kind of piecewise function. Notice how this part is saying to use this function x cubed plus 7 when x is anything except 1, right? So when x is not equal to 1, you use this function. So basically for all real numbers, right, except 1, we're going to be using the x cubed plus 7 here. But what happens for when x is equal to 1? Well, we're going to use 2x plus 1. Okay, so in that special case when x is 1, we're going to be using that green function that I've highlighted there, the 2x plus 1. So my first question to you is, what do you think f of 1 is? So you want to look for the piece when x is equal to 1, right, to find the function value. And so the green piece, right, is where the function is defined when x is 1. So remember, here what I'm going to do is just plug in 1 for x. And so this will give me 2 plus 1, which is 3. Okay, so I should have f of 1 there is 3. But now, what piece should I use to find the limit as x approaches 1 of the function? Okay, do I need to use both pieces and consider left-hand and right-handed limits, or can I just use one piece? Well, even if you considered the left-hand and right-handed limits, all right, looking at a number line, we have our value at 1, right? And all this is saying is basically when you're to the left and to the right of 1, you're using the function highlighted in yellow, except when you're at 1, that's when you're using that green function there. So when we're approaching 1 from the left and from the right, x approaches 1 from the left, so that's this region on the left, x approaching 1 from the right, the region on the right, we're still using that function highlighted in yellow. Okay, so we don't need to necessarily consider the left-hand and right-handed limit because it's going to be of the same function. All right, and so if it makes you happy, you could do it, but you're going to get the same answer here as if you just said that this is the limit as x approaches 1 of x cubed plus 7. Okay, and then from here, just remember to plug in 1 for x. So this is 1 cubed plus 7, which is equal to 1 plus 7, which is equal to 8. Okay, and just to show you what I'm talking about, you could have said that the limit as x approaches 1 from the left of f of x is equal to the limit as x approaches 1 from the left of x cubed plus 7, which again, same idea, plug in, you get 8. And then here, you could set the limit as x approaches 1 from the right of f of x, which again, coming from the right, is the same function, x cubed plus 7, and so this is 1 cubed plus 7, which is equal to 8. Okay, so it's not necessarily wrong in this case to consider left-hand and right-handed limits also, just like we did in practice 2. But here it's just a lot faster if you just consider the limit as x approaches 1 of the function in yellow. Okay, because we know that we're going to be using the exact same function for left-handed and right-handed limits in this case.